All right, now, I understand that's probably scary, but what questions do you have? If you don't have any, that's fine. Don't worry, we'll do more examples. Yeah? All right. All right, so now it's good to do some more examples, so let's do that. Okay. So here's another one. Oh, excuse me, this is the same one actually. Oh, that's why. I forgot to say this. Once you factor down here, if you can factor any further, then you should do that. Here you can't go any further. We factored as much as we can, so we don't have to factor anymore. Right? Because x minus 5 cannot be factored any further, and neither can x squared plus 3. Normally, when you get to this step, you want to factor further if you can. But what I'm saying here is you can't. So factor all the way down. Basically, if you have anything in this form, x minus b or x plus b, where b is not 0, you can't factor that any further. And x squared plus a non-zero number, that also cannot be factored. Actually, that should be positive. Yeah. That should be positive. There we go. All right. X squared plus any positive number like 3, that cannot be factored any further. So, all right. Now let's do another one. Okay. So again, we finished this one, right? Once we got all the way here, we cannot factor any further, right? As I said, x minus 5, you can't factor that any further. X squared plus a positive number, you cannot factor any further. Mostly because we're not dealing with complex numbers. But let's do another one. So here's another example. Okay. Now again, let's get the GCF of the whole polynomial. All right. Well, right. Okay, so there's a non-zero constant term. And whenever that happens, as we have seen already, in the GCF, your m is going to be 0. In the GCF, your m is going to be 0 in that case. Now notice that 2 is a coefficient and 2 is a factor of every term. So 2 is a coefficient and it's a factor of every coefficient and the constant term. In other words, the greatest common factor among the coefficients and the constant term is 2. I mean, you could list all the factors of each one here, but what I'm trying to show you is you don't have to. You know, the factors of 2 are 1 and 2. For 4, the factors are 1, 2, and 4. And for 8, it's 1, 2, 4, and 8. And if you did list them, you would see that 2 is the greatest common factor among the coefficients and the constant term.
So we can't just start grouping like something that I was confused on. So like for this one, I tried to go ahead and do it, but I started grouping immediately. Like I just put 2x cubed minus 4x in one group, 4x minus 8 in another group. But you have to factor out the GCF for the whole thing before you can group, right?
I mean, technically, what you're doing is correct. You could just dive right in if you want to. I just like to tell people to do the GCF first. I think on maybe not in this example, but there are certain examples where it can make things easier.
So I can start grouping immediately, but you're just saying
of course.
Okay,
yeah,
you should get okay.
You can do that, yeah. You can. I mean, if you were to dive right in and start grouping, I'm not going to take points off, so I wouldn't do that. Okay. I just thought it'd be easier if people took out the GCF first. So, okay. Okay. Good question. Are there any other questions at all? Okay. All right. So basically we get the GCF is 2, and we just factor that out, as you can see. You put it in front, and then you divide like so, into each term. And when you divide into each term, right, the first term here, the 2's will cancel. We get x cubed. Here, you have 4x squared over 2. That's just 2x squared. Here, 4x over 2 is just 2x. 8 over 2 is 4. So that's what happens here. And now, let's do factor by grouping on this polynomial. Okay. So now, what do? We form two groups, right? And again, it's good to have addition between the second and third term. As you can see, we have addition here. Mostly, it just makes it easier to use parentheses. Otherwise, you have to worry about taking out a negative. I mean, I'm hoping today we'll see some examples of that. So we have these two groups. And for each of these two groups, we're going to factor out individually, we're going to factor its GCF out. So for the first group, the smallest exponent of x is 2, right? Notice there's a coefficient of 1. So we have m equals 2 in the GCF. B would be 1. So the GCF would be 1 times x squared, which is just x squared. Right? So again, we have 1 here, and the only factor of 1 is 1. So the only common factor one can have with any number is 1 itself. That's why the greatest common factor of the coefficients is 1. The smallest exponent of x is 2. A GCF is x squared then. Then we factor that out. So we have x squared times the polynomial over x squared. Right? By putting it in front, you're essentially, well, that's right. Then we divide into each term. X cubed over x squared. Again, you just subtract the exponents. We get x at 2x squared over x squared. The x squares actually cancel. We get 2. Good. 2x minus 4. Right? Again, the smallest exponent of x is 0. Right? So m would be 0. There's no x term here to take out, in other words. For 2 and 4, right? 2 is itself a factor of 4. So the greatest common factor among 2 and 4 is 2 itself. Again, you could list the factors of each if you want to. I mean, the factors of 2 would be 1 and 2. The factors of 4 are 1, 2, and 4. But 2 would be the greatest common factor of the coefficients and the constant term. So for this, the GCF would be 2. Factor it out. We divide to see what's left over. Like so. We divide into each term. We get 2 times x minus 2. And that's what we get. So notice from the first group, in parentheses, we have x minus 2. From the second group, we have x minus 2 in parentheses. That's good, right? Remember, you want what's in parentheses to be the same among both groups. Right? So again, here, I'm just substituting. And we get this line. Right? And again, in parentheses, we have the same thing. That's good. Because then we can factor it out. But you have to figure out what's left over, so we divide. right? When you divide, that's the same as dividing into each term. This cancels with this. This cancels with this. And so we're left with x minus 2 times x squared plus 2. Okay, that's good. So what we have is this here, right? We have this polynomial, which is the same as this sum. Right? So that's equal to x minus 2 times x squared plus 2. But again, the original polynomial, we had to take out the GCF of 2. And so I put the 2 in as well. Okay, awesome.